Okay, so we are going to talk today about the last two triangle congruence reasons you can use to prove triangles congruent. Now, at the top it says today we're going to explore 4 possible triangle congruence criteria, except we're actually not going to get 4 to work. We're only going to get 2 to work. That's why it says FYI, 2 of these don't work. So the 4 that you haven't seen yet are AAS, SSA, or sometimes we write it as ASS, hypotenuse leg, which we abbreviate as HL, and AAA, which stands for angle, angle, angle. So let's talk about which ones work and which ones don't work, and then we'll go from there. So the first one we have is angle, angle, side congruence criteria. So if you look at the picture here, here's an angle that matches up with this angle and that one. And then I have this side that's not between the angles. That's why this is AAS and not ASA, because it's not the included side. So what we're going to put over here is if 2 angles and the non-included side of one triangle are congruent to 2 angles and the non-included side of another triangle, then the triangles are congruent. That's AAS, angle, angle, and the side outside of it. AAS. Now, why does AAS work? We got to prove the reason that the other ones work. Well, it's because AAS, in a way, is like a shortcut for ASA. Since I know that 3 angles of a triangle have to add to 180, if I knew this one and I knew that one, by default, the third already has a value that I may or may not know, but I know that that third value has to match up so that both of these triangles add to 180. So AAS kind of shortcuts us into saying, you know what, if 2 angles of a triangle are equal, then the third has to be equal as well. And that's actually a reason you can use in a proof too. So if 2 angles of a triangle are equal, then the third angles have to be equal as well. But long story short, we have AAS. Once you have the 2 angles, you've got the last side. You can say the triangles are congruent. All right, moving on. Side, side angle, or ASS. You are not allowed to swear in math. So this is one that we're actually not going to be able to use, and I'm going to prove it right now. Observe the diagrams below. Each triangle has a set of adjacent sides of measures 11 and 9, as well as the non-included side of non-included angle, pardon me, of 23. So here's my 11 and 9 here, 2 sides, and the non-included angle of 23. Here's another 23-degree angle with an 11 and a 9, okay, and these are drawn to scale. These triangles are obviously not the same, but they have angle, side, side. Angle, side, side. ASS actually can create 2 different triangles. And if you want to see them kind of smushed together here, what happens is when I have angle, side, side, this is a fixed measure, this is a fixed 11, and then this 9 can kind of dangle out this way, and like a pendulum could swing back and forth. So I could have a 9 out here, or I could have a 9 in here. But long story short about this big picture is that ASS or SSA, no matter what you call it, is not a thing. You are not allowed to use that as a reason. If you find that you have that as a reason, you need to keep looking for another side or another angle to help you out. Now, AAA, let's see if this works. Sketch 2 different sized equilateral triangles. Okay, so equilateral triangles have 3 equal sides. So these are obviously different sizes. So if this is congruent and that's congruent, what's the measure of each interior angle? Well, if it's equilateral, it's got to add to 180 degrees, and that 180 degrees there has to get divided equally amongst 3 angles, so that's 60 degrees apiece. So these are all 60, and these are all 60, right? So 60, 60, 60, 60, 60. So I've got all of that. Now, what am I supposed to do with that? Wait a minute. These 2 triangles have 3 of the same angles, but they're not the same triangle. In other words, AAA does not prove triangles congruent. AAA can make similar triangles, but of different sizes. Okay, so what did we just learn on this front page so far? We have learned that AAS is okay, but we've learned that SSA, also known as ASS, and AAA, none of these guys, not okay. Okay? So AAS, good. ASS and AAA, bad. Not going to use those. All right. And last but not least here, we have what's called hypotenuse leg. And this is one that does work. Hypotenuse leg, what kind of triangles have a hypotenuse and a leg? What kind of triangles have a hypotenuse and a leg? Ooh, I see it. It's right triangles. There's a right angle right here. So here's how it works. In two right triangles, if they have a pair of congruent legs and a pair of congruent hypotenuses, then the triangles are congruent. So if I have two right triangles, right angle, leg, leg, hypotenuse, hypotenuse, I call this HL, and I can say, you know what, these guys are equal. Okay, so now we have another happy face. So up here we had happy face AAS, sad face here. Now we have a happy face HL. Okay, so we have our 3-letter theorems, and now we have HL, a 2-letter theorem. But these 3 letters, bad. Can't use those. Okay, wait. I just said ASS doesn't work. Doesn't this look a lot like ASS, an angle and 2 sides? ASS? Yeah, I just told you that doesn't work, but now all of a sudden it looks like it does. Well, here's the magic of this one. This is hypotenuse leg. This isn't just any angle and 2 sides. It's a right angle and 2 sides. And the reason this one gets to be special is because of the Pythagorean theorem. So if I made a triangle, right like this, and I told you this was 3 and this was 5, and I had another triangle, and I told you this is 3 and this is 5, to find that third side for both triangles, you would say a squared plus b squared equals c squared, and you'd get 9 plus b squared equals 25. B squared is 16, square root both, and you get b equals 4. In other words, the Pythagorean theorem says if you know 2 sides of a right triangle, you could automatically find the third using Pythagorean theorem. Okay, so HL is the one time ASS works. So often what I tell my students is if you find yourself in a situation where you have ASS, but it's a right angle, then you're allowed to use it as long as you call it HL. If you have ASS and it's not a right angle, you can't use it. All right, so let's cull all of this information together and actually make it a decent whole. Let's see, what's my time so far? 8 minutes. All right. So what do we have so far that we're allowed to say? Well, we just said we have HL. We also just found out we have AAS, okay, which I'm okay if you call it SAA. We don't normally call it that, but I'm cool with it. So we have HL, we have ASS, and then AAS. Then we also have ASA, where the side is in between. We also have SAS, where the angle is in between, and we have SSS. These are all happy ways that we can actually prove 2 triangles congruent, okay? I call these the 3-letter theorems a lot, even though HL isn't actually 3 letters. I just kind of roll it in there. All right, so those are 3-letter theorems that are good. 3-letter theorems that are bad, we just said AAA does not work. And we also said ASS doesn't work. Even if you try to pass it off as SSA, it's still bad. You cannot use these. Those are bad. Don't write them down. You won't get credit. They don't work. And the reason they don't work is they make too many different types of triangles. These on top all make unique triangles. These on the bottom could make different triangles. All right, let's do some proofs. Make sure you understand how these work, and then we are done. All right, I'm aiming for 15 minutes or less here. So let's see. Let's start with this guy. So I have given that AB is perpendicular to BD. ED is perpendicular to BD. Oops, sorry about that. BD bisects AE at C. So this guy got cut in half at C. Okay, let's see. I've got, all right, well, that looks pretty good here. So let's prove these triangles congruent. So step one is to rewrite all of our givens here. And BD. Somebody asked me once, do you have to put these on one line? Can you put it on 3 lines? Honestly, the rule is however many lines it takes you to write it out. There is no rule for it. As long as they all have a reason of given, you can write it on as many lines as you want. All right, so I got my perpendicularity and my bisector. That was given. Okay, 2. So next thing, perpendiculars. I've said it before, I'm going to say it again. When you have perpendiculars, perpendicular lines create 2 statements and 2 reasons. Statement number 1, identify the right angles. That would be B and D. Angle B and angle D are right angles. Why are they right angles? Because of that symbol, that perpendicular symbol. Perpendicular lines form right angles. So when you see perpendicular, 2 statements, 2 reasons. B and D are right angles because of perpendicularity, and all right angles then have to be congruent. It takes 2 steps. B is congruent to D because all right angles are congruent. All right, all right angles are congruent. Okay, so now I've got this proved. Cool. 4, what else was in my given? Ooh, bisect. AE got bisected. So AE, whoa, AE right here got cut in half, making AC congruent to EC. Why do I know they're congruent? Because of the word bisect. Bisectors create 2 congruent segments. Okay, that's cool. All right, so now I have an angle and a side. I could use another angle or another side. Oh, I can use the picture. So I have the angle, the side, the side. These are vertical angles. So for 5, I can say angle ACB is congruent to ECD because vertical angles are congruent. That's cool. And now if I look at my picture, I have 3 marked things, 2 angles and a side, but the side is not in between them. So this would be AAS. And this is also AAS. And AAS, yep, that's on my list. So I can say triangle ABC is congruent to EDC by AAS congruence. I'm waiting a second to let you get it all copied down. Okay, I used my givens. Perpendiculars created 2 statements, 2 reasons. That bisector created a statement, and the picture created a statement because the picture visually gave me vertical angles. I marked my diagram. You should always be doing that. And now I have some congruency. How am I doing? Oh, 14 minutes. Holy cow. Time flies when you're having fun. You guys are thinking, yeah, right. All right, I got to get through one more here. I got to get through an HL proof. So let's do, let's do this guy. All right, given that NQ is perpendicular to MO and Q is the midpoint of MO, you know what? I can't edit this video. Let's skip that one for a second. I have a better idea here. What's my better idea? My better idea is over here. I'm sorry. We're going to do example 1 and example 2. I'm sorry if I made you dizzy. Sorry, sorry, sorry. My only excuse is that I'm distracted by my cats who are currently climbing over the keyboard. All right, so I have statements, I have reasons. Okay, what do I got here? I got this big thing. AB is congruent to CD. AD is perpendicular to CD. And CB is perpendicular to AB. Cool. All right, there's that perpendicularity issue. Okay, so perpendiculars. Perpendiculars create two statements, two reasons. Step one, identify the right angles. Angle B and angle D are right angles because perpendicular lines form right angles. 3, angle B is congruent to angle D because all right angles are congruent. Let's see, that was given. What else do I see here? What else do I... Ooh, these two triangles share a middle. AC is shared. So AC is congruent to AC by the reflexive property. And I have ASS. Oh, dang it. I can't have ASS. Wait, if I have ASS with a right angle, which I do, I get to use HL. But here's the annoying part. HL is a two-statement, two-reason issue. The first thing you have to do, once you realize you're going to use HL, is tell the reader that you know you have right triangles. So I got to come over here and say triangle ADC and triangle CBA are right triangles. How do I know that? Well, duh, because they have right angles. Then I'm allowed to say ADC is congruent to CBA by HL congruence. 2 at a time. HL uses 2 things. Okay, so once you realize I want to use HL, you have to identify your right triangles first. All right, that's the rule. We are done. I'm sorry this was a long video. The crappy joke is, why didn't the skeleton cross the road? Because he didn't have the guts. I know it's terrible, but it's Halloween. I had to pick something. Have a good day. I'll see you guys later. Bye.